Welcome, math enthusiasts. In this video we're going to talk about one-sided limits and how to find them numerically. So one-sided limits look something like this. Limit as x approaches -1 of a function. So whenever you're approaching an x and you have a positive or positive means you're approaching from the right side, and then negative means you're approaching from the left side. Negative means you're approaching from the left side. Okay, so first, in most cases you won't have to make a change to the function, how the function looks, but sometimes you have to in order to get the value that you need. Usually what you have to do is you have to put it in lowest terms, or you have to factor and then cancel out terms for rational functions. This one looks quite simplified, so we'll just leave it like that. What we're gonna do is since we're approaching -1 from the right side, what we're gonna do is we're gonna choose values coming from, so -1 on the number line looks like this. This is -1, so here is 0, here is 0 point, -0 point, this will be, let's do it like this, -0.999, and then -0.99, and then -0.9, and then 0. So let's pick these values and then create a table, so that way we'll find what the limit is to find it numerically. So let's create a table. So let's put 0 here, then -0.9, -0.99, and then -0.999. Remember, we're approaching -1, so -1, so we start with the bigger, we start here with 0. 0, we're gonna, if we plug in 0 here into the function, that will get 1 over 0 plus 1, that's just 1. Then if you compute this with a calculator or by hand, you're gonna get 10, 100, and then 1,000. So looking at this table, the limit as x approaches -1 of 1 over x plus 1. So remember, we're approaching -1, so this from here like this, we're approaching -1, so it's getting bigger. That means that the limit is increasing fast, so we're going towards infinity. So the limit is equal to infinity. That is problem number 1. Let's look at 2 more problems just to get a hang of it. We're always going to create a table. So first, let's write the problem. Limit as x approaches 0 from the right side of 2 over sine x. So now let's create a table. Remember, we're approaching 0 from the right side. That means that we can start from 1 and decreasing it. We'll start from 1, then 0.1, then 0.01. So we're approaching 0 from the right side. That means this one could be 0.01. Look what happens. I already calculated this for you, so you just have to plug in these values into the function. you're gonna get 2.38, then 20.03, then 200.03, then about 2000. So as we go approach 0 from the right side, we're getting bigger numbers, larger numbers. So this is approaching quickly to bigger numbers. So we're gonna say that this limit approaches infinity. So this is problem number 2. You can see it's getting bigger, so it's approaching infinity. There is no, it's not getting closer to a number, it's just getting bigger. That means that it's approaching infinity. From the right side. Let's do our last problem, problem number 3, to get a hang of these one-sided limits. Limit as x approaches pi from the right side of square root of x over cosecant x. Notice what happens if you plug in pi here. If you plug in pi here, it's not gonna work. So what I suggest to make this problem easier is if you change the form of this limit. So you can write it as limit as x approaches pi from the right side of square root of x times sine of x. So sometimes we're gonna get infinity or negative infinity for answer. Sometimes we're gonna get a value. Let's see what happens. So we're approaching pi from the right side. So let's choose some values numerically. But sometimes you gotta try the number that they give you, because that might be the answer. Just plug it in, that might give you the answer, but not always the case. Sometimes you're not gonna get you're gonna get a denominator equal to 0, so that doesn't work there. So it's better if you start, you always create your table and see your values and see what is approaching. So let's choose this one. Remember, we're approaching pi, so let's choose pi plus 0.1, pi plus 0.01, then pi plus 0.001, and then let's choose pi. Remember, we're approaching from the right side, so we're approaching here. So what do we get here? Well, let me give it to you. So here, these we're gonna get 0. Here you're gonna get 0.02, negative 0. I'm sorry. 0, 2, and then here you're gonna get 0, 2, and then here negative 0.2. So notice, as we're approaching pi, we're approaching a smaller number, but see, this time we're not getting we're approaching quickly to the value, and then actually we approach 0. If you plug in pi into this function, you're gonna get 0. So, and notice the closer we get to pi, we're approaching 0. So that means that the limit as x approaches pi from the right side of square root of x over cosecant x, which is the same thing as square root of x times sine of x, is equal to 0. And that's your answer. So in this case, we didn't get infinity. We got a number. So thank you for watching, and please subscribe to my YouTube videos. Thank you very much. Bye bye.